the machine, the PX3000, the first introduction on technology, on the components. Most of you already seen the machine, so it will not be a big surprise on how this machine is looking like. So the Panther machine and technology is based on inkjets, and we use Kyocera inkjet heads from Kyocera, so it's not our own design. If you look to the head and you take a head out, you will see their label. Yeah, but for the time being, with our inkjet that we now, with the PX3000, is only focusing on the label market, not on the document right now. No. Right now not. So besides the Kyocera head, which is a pretty okay head, I'm not saying it's the best head that you can find on the market, I don't say that. But for price, quality, it's quite okay, it's a good head. Then we have our ink, UV ink that we selected. Fortunately also here we're marking it to our name, but it's not made by us, unfortunately. Not yet at least. And we also have LED UV. And they have different kind of frequencies. And they are all used for better fixing. Well, the LED will more heat or cure, let's say, the surface, the bottom actually close to the paper, because the radiation goes deeper into the ink and starts to cure here more. While the bulb is more curing on the top, so it's more for scratch resistance. And then we also have developed a new screening technology for this Panther. The screening technology is actually more frequency modulated screening. It's FM screening. The dry toner uses AM screening. It's dots which become larger. That's AM. Yeah. But with the screening technology, Dionysius screening is actually frequency modulated. So FM, or how you call it also, dithering screening, or they call it sometimes also stochastic screening. Stochastic, that is random screening. The dots seems like randomly placed on an area. And stochastic, that are the three words. But there's a different kind of technology which is used. And of course, but not last, this whole Panther is of course connected to X800, which gives a nice quality in color management, in position, and those kind of stuff, of course. This is in basic what the machine is all about. So we have an unwinder, we have a rewinder, we print first with white, and then we print CMYK. That's a bit strange. I find it strange at least. But that's still the same here. So the white is still used as first. That definitely is separate. And then we have the CMYK. There's no way to change the colors here. That's not possible. Yeah. So why? Because theoretically you could, but you see that there is something extra there. Pinning LEDs. Pinning LED. Yeah? So we print white, and then we have a pinning, and then CMYK, pinning, and then we have our UV stuff. What are those pinning things? Pinning is also UV. It's also LED UV, yeah, but less powerful. This one here, the LED UV, is relatively powerful. It needs to be cooled. It's prefixing, indeed. You're right. Yeah. Is a prefixing, so we do that on both levels, after white and after black, but for different reasons. For the white, we do that to make the liquid, let's say, not super hard, but not liquid anymore. I mean, if you then print yellow, cyan, magenta over it, it stays on top. It doesn't sink in. It doesn't mix. It's not. So you want actually that the next colors, CMYK, are sitting on top of the white. So you can play around with the pinning from 0 to 100%, but normally if you go to 80% or so, it's enough. But you can play with that. The more you pin, let's say, the quicker you're going to harden the ink. If you want a more, let's say, equal layer, then you would pin a little bit less. But if you less and less power, at a certain time your color CMYK will start to integrate or sink into the white, and then of course not good anymore, because then you lose color. Once a cyan particle falls underneath a white particle, by matter of speaking, then it's not visible anymore. You lose that pigment, you lose that ink. Eh? And then for black, we actually use it more for sharp texts. If you want very sharp text, you want that after the black is being on the sheet, on the label, that it immediately, let's say, hardens, by matter of speaking, that it doesn't float out, because then you get a more unsharp text. For very small lines and text, it's important to do pinning after black. But on the other hand, if you want to have a black surface, then of course if you harden immediately, you might see more lines because the ink droplets that create sometimes a little bit lines. If you want more flowing, if you want a more nice shiny general black surface with not any lines in there, then you should reduce the pinning. But that's a little bit the balance you have to take between too much pinning is maybe still some lines that are visible in your black areas, but too little pinning is more unsharp text. You need to print a particular width, and we want to go for 330 millimeter wide printing on our label stock, 330. And unfortunately, as far as I know, in commercial way, there doesn't exist one print head which is that wide, with that width. 330 width doesn't exist. Maybe it exists in some kind of lab or so, but as far as I know, commercially available and reliable and stuff like that, it doesn't exist. What they have is Kyocera heads, which have a width of 160 millimeter. But actually, if you would see how the design is, I will show you this design in the next slide. Yeah, you see over here that actually these are sections. And a section is not straight. Xeikon head is more straight, but here this is actually sloped. And if you put this head together with that head, all those pixels here of that zone here, part of the pixels are coming from this head, but another part is coming from that head. And they so-called merge together a little bit. And they do that so the hard border is in some way better designed. How they figured out that is better, I don't know, but they feel that this kind of technique gives them the possibility to combine multiple sections. Actually, you see here one section of a head, U1. This is the master design, and they managed to put 1, 2, 3, 4 of those sections in one head. Yeah, okay, but what they could not do is to put 5, 6, 7, 8, 9 in a head, and it's just said, look, if you now take a second head with the same design, you can use the same technique of overlapping this section with that section, is this section with that section you overlap. It's a little bit the same idea, yeah, okay. Now, but that makes that, of course, the pixels that you see here on the edge are not usable. You cannot use those. Those are only usable if you would have here an extra head next to it, because then those small pixels will collide with the pixels here, and that forms, of course, the rest of the line. But this beginning here is not exactly all pixels filled. You follow a little bit what I find it very difficult to explain, but I hope I make myself clear. Yeah, it's clear? Yeah. Okay. So that makes, if I go back to the previous slide, that for the edge heads, only 108 millimeter is possible, but for the middle one, the 116 is usable. So if you calculate that, then you come to 116 plus 116 for the edge. Sorry, that's wrong. Plus 108 for the edge on the one side and 108 for the other side. That together is 334. Yeah? Am I right? Or 2? Sorry, 2. Not correctly. That is the amount of pixels you would be able to use maximum on a 3-head system, like you see here. But to be on a safe side, we leave 1 millimeter on one side and on the other side not as imageable, so we can still shift a millimeter pixels on digital level to the left or to the right. You could use it for registration purposes or something like that. Yeah? Okay, so that makes that the maximum imageable width that as X800 we support 330 millimeters. Okay, now the web width is maximum 350. So there's more room on the rollers and on the whole print bed and stuff like that to put there a web which is 350. So way wider, let's say, than the maximum imageable width that we can use. And as we talk about the PX3000, we also, as you know, have released in the same time a PX2000, which is actually built by 2 heads only. Yeah, only 2 heads are possible there. And how much millimeters do we have then?
They're overlapping, right?
But you only have to. The only thing what you miss here is a part here that you miss. Then you have your heads. Then you have over here, yeah, the other heads like that. That one you can still use, but this part again you miss. So what you actually miss is 1 head. So for 1 head you have to count 108, and for the other head you can count 116. So the sum of those two, that's the maximum imageable width. 224, but I think we go for 220. That's the maximum imageable width that we support for the PX3000. If I'm not mistaken, let me quickly check that. The PX2000, as you see, 220. Yeah? So we take there, okay, we have 224. That actually means 2 millimeter more on the left side, 2 millimeter more on the right side, where we can shift instead of 1 millimeter is 2 millimeter on both sides. So there we have a little bit more space for shifting, but basically it doesn't matter that much. Okay, so that's how it's been built actually. So we make use of in total 3 times 5 heads, that's 15 heads. 15 pretend. Now, one extra information, these heads are of a different type than those heads. And this is different numbers, type numbers, let's say. I don't know by heart, but one is a TA version and another is a T version. Oh, I forgot already which version it is. But anyway, it's a different, so if you order a spare part, you have to specify, are you for the CYK or for the whites? It's different spare parts, a different type. It's also to do with I think these are normally not used for flutro, that the ink goes through, yeah? While the whites we do that. White is circulation ink, so ink comes in and goes out again from the same head to a circulation system, yeah? While these are not used like that. I think theoretically you could use it like that, but they're not designed for doing that anyway. Yeah? You saw already how a head is being built. Now this is confidential information. Normally you should not see that. But anyway, let's say I found it somewhere on the internet. That's how a head is being built. But if you would if you take a head and you would put under a microscope, you see all the little dots there, they're all the nozzles. And as you can see, they're built in multiple rows. So we have, now I have to think again, I think 2, 4, 4, or 2, 4, 4, 3, or 4, 1 with LEDs. We have 1 LED strip, and every LED is next to the other one. Yeah, it's only 1 row. But with this kind of heads, you see, it's a rather complicated setup of nozzles, and that gives us issues. It could give us issues because what is important is that the timing. If you give the nozzle of this one here, for example, yeah, then this should fit exactly in, let's say, this nozzle and that nozzle, yeah, exactly in between. But if in the meantime the paper would shift a little bit, although it's only 10 microns to the left, yeah, then that nozzle, which was shooted first, is not exactly in the middle of the two, but maybe a little more to the left or more to the right. And that might be sometimes visible. Yeah? So web stability is very important. If the web high frequency does this, you have all kind of issues. And I'm talking about already this here, but you can imagine that here it's even worse. From here, this pixel here should be printed between maybe that pixel and that pixel. But in the meantime, the web went this, yeah, you have what they call stitch issues. Yeah? You see that it's not nicely interconnected. There's kind of shifting. You see lines appearing. Yeah? That makes it actually, that's one of the difficult things in inkjet, yeah, is where 2 heads come together, that you don't see any lines there. But with this, the thing is also, so when paper moves, but if the paper runs in this way through the machine, and the next time you tweak and tune it so the 2 heads are nicely aligned so you don't see any lines, but then a little bit later, the paper moves more that way through the machine, there it goes, and you can start tweaking again and say, what's this now? I see lines with this material. But this material, for some strange reason, runs a little bit more this way through the machine, and the next material, after doing some stuff, runs a little bit more that through the machine. and say, I see pitch problems again. And what you're going to do then as operator, are you going to then start tweaking, calling service engineer, or are you going to say, yeah, well, that's inkjet, let's keep on printing, yeah? That's the quality of inkjet. Well, the first time, a new customer will call you. Maybe a month later, he will start to tweak himself, and maybe 4 months later, say, that's inkjet. Forget about it, yeah? Because he keeps on tweaking and tuning forever, and say, come on, I cannot keep on doing this forever. He might still do that from time to time if it's a very important, high-quality job. Then he might say, okay, let's do an effort to tweak it again good, because this job is important, it must be good quality, and I see it on this job, I see it, let's quickly try to tweak it again. But on many jobs, you might say, well, on this job, it's not that visible, keep on printing, yeah? So if you have one line here, 40 micron, and one line here, 40 micron, and if you then have to print another line in between, normally it should be exactly here in the middle, but if it's now even 20 micron or 15 micron more to this side, what's going to happen? And these two lines, they collide. Ink has the tendency, if two ink droplets come too close together, they attract each other, and they will move together. And it creates actually here a white area which is actually bigger than the difference that you originally would pure mathematically would see. Hey, there's maybe only a shift of 10 micron, but if due to the colliding on and ink droplets, they attract each other, you create actually a gap which is wider than the 10 micron or 50 micron that you initially would see, pure theoretically. But you'll see 25 micron gap, and that's very visible. So you must be able to place actually that middle row perfectly in the middle of the other two. The least amount that you go to the sides, you're 20 micron off, you immediately will create lines. You know? That's the difficulty of, and of course not for every material it's the same. Some materials have way more that tendency of colliding than others. You know? Depends also on the droplet size. How much volume you put there. That makes also a difference. Where for some densities you don't see it, and for densities you see, hey, what's happening? Your lines here on this density. It's there where just the volume is so much in ink that there the droplets will collide. They're big enough to start to attract themselves together. And with other volumes, the pixels are still in the middle, and they're still far away from the edge pixels, and so there's no way to move it to one or the other direction, so it stays, okay, a little bit mistuned, but not that much visible. But if you have so much more ink, then everything is filled with ink. And if it nicely flows on some materials, you have enough flow, if you don't put pinning and stuff like that, then you even don't see it anymore, because everything is so much flowing that all those ink will become one pool of ink, and those lines will be gone. Yeah? So it also depends a little bit on what density, on what material are you printing, whether you would see that effect that I was just describing. Okay, first day I'm already in troubleshooting, but anyway, this is a very, let's say, one of the tasks and one of the difficulties in inkjet is that whole stitch thing there. Stitch and now I must say, what heads is concerned, we had over the years that we're now busy already with the machine. Many times, yeah, nozzle issues, issues where the nozzles gets blocked. But the more we are now giving guidelines to not switch off the machine anymore, we have less and less issues. So right now, the machines are permanently on. My press, everything on continuously. We never ever shut down the machine. And since then, actually, we don't have that much of an issues. It's typically issues when people are switching off the machines and the ink is settling and for a long time not doing anything. I have the feeling that the amount of problems we have become more and more. Kyocera heads 600 dpi. However, I say 600 dpi, but for white, only for white, we have the ability or the system to put in across direction 1200 dpi. Because in along, so the head itself is 600 dpi, that we cannot change. But instead of printing one line, we print two lines. Yeah? We double the pixel amount, and so we come to 1200 dpi in that direction. So 600 by 1200 dpi is possible for the white. For the color CMYK, we don't do that. Only for the white, to create even more opaqueness, more heavier white on the system. We say the maximum speed is not 50 meters per minute, but 25 meters per minute. And so the firing frequency for white is equal to as if the web would run 50. Yeah? It's the same idea, but unfortunately the maximum speed of the web is reduced to half. So the frequency of the head is a maximum particular frequency, and we use it for 50 meters per minute as the maximum what the head can do at 600 dpi is a particular frequency. We cannot go over that. So the white head is not able to do double frequency or so. That's not possible. It's the same frequency, but if we halve the speed of the web, if the web runs half the speed, then it seems like we double the frequency, of course, but it isn't. The frequency of the CMYK heads will halve to stay at 600 dpi. If the speed halves, the frequency of the heads will also halve, but not for white. For white, it stays the high 50 meters per minute frequency to create a double line, let's say, double jetting, like we also sometimes call it in the user interface. We call it double jetting. We shoot two lines where normally we should only print one line, and that creates more ink. Of course, the usage will be also more. You have more double amount of picoliter or liter per square meter or whatever. We also have ink tanks, CMYK ink tanks, which are large enough to print sufficient, of course. And we also have this here. There are white tanks, even two of them, with white gray caps, inked. So this white thing here, that's what I was actually wanted to show. And this white thing is not white ink. No, it's actually solution, or what they also sometimes call flush. It's also called solution. It's a very strange, very wide word like solution. But what kind of solution? They don't tell us what kind of solution it is. It is kind of liquid, and that liquid they use for cleaning out heads. So if you want to replace a head, then you're first going to put it on solution. You're going to flush it. That's why they also sometimes call it flush, is to flush the ink out and replace it by a different liquid, what we call solution, or in short, people also sometimes call it flush. And anyway, it is a transparent or a non-color liquid. It's like, you might say, like kind of oil. It's not oil. It's a different kind of solution, but a kind of oil look. So transparent, not colored, and it also doesn't cure. So when you put solution on the paper, it will not cure. It will stay liquid. It stay a mess. So never print with solution. Only print with real ink. But sometimes you need a solution to when you want to take out the head and you want to put it aside. You don't want to have just ink in there, because that will, with light and UV, it will harden in there and you can throw away the whole thing. So and the head is always shipped with a kind of solution in it, a kind of non-curing liquid in it to keep the heads healthy. Indeed. But also sometimes for getting rid of blocked nozzles, sometimes we can try to push the debris out with the flush. Instead of with ink, but with flush. Flush is a little bit more liquid, let's say, less viscous, and has more ability to clear out the nozzles and to clean out the nozzles, at least for CMYK. For white, for the time being, it's a little bit more complicated. I will explain that later. There we right now say, for all the machines, as from now, actually from last month, never ever use the flush for white. There's only very specific reasons why you would use flush for the white for the time being. It seems that the flush that we have right now is not mixing very well with the white ink, and creates all kind of little clumps, which creates, of course, blockage. So the current flush that we use right now is not compatible with the white ink. So, or you fully flush it out completely, where you're sure that there is no ink whatsoever, nowhere anymore, then it's not a bad idea. It still needs to be done. If you replace an LDA, take it out, then you have to do it still. But just for fun, or to keep the head in flush for a while, and to survive over the weekend or over a long holiday or so, never ever do that for white. For the colors, you could still do it, but it's not really needed to do it actually. So where initially the flush liquid was there and is actually by R&D and also by training and by demo and by everybody used very regularly, actually the guideline now for the future is that flush, okay, it's in there, but should be rarely used. That's the idea. Yeah, not for any color. Even for CMYK, normally there should not be a need to put a head on flush. If you follow all the regulations and all the maintenance actions, then in principle there is no need to use flush whatsoever. Yeah, no, the flush system we're not going to remove, we're going to keep it there, but in the manuals we still are more writing down that in this and this and this and this and this circumstance you have to go for flush. And what we have to replace that by saying no, do this and this and this maintenance actions, and flush you should never use. Solution you should never use. A last resort. Yeah, or if you have to take out the head and you want to store it for a week or a month or so offline, then you need to go in flush. Or if you want to ship a machine to another customer, or you're going to take it offline for a month or 2, 3. Yeah, then you're going to put them in flush. You're not going to keep the heads in ink. Then you would use flush. What? Also for white. But then you fully flush it. Yeah. But basically in my manual still indeed, you will read many times, oh, here you do flush, and if you do this, put the heads on flush. All those things I have to remove. I have to say, no, keep it in ink, keep it in ink. It's only when you want to take a machine offline or want to replace a head, then you go for flush. And in some other small reasons also, but I have to come to that later. Now for the white, since this white stuff is solution, yeah, this is solution. Where is then the white? Well, the white container is this here. So next to the yellow, you see it here already a little bit. No, sorry, here you see it already a little bit, but here you see it more, yeah, it's kind of bomb, yeah. You might say, which wire should I cut first before the bomb explodes? It seems like it's a complicated thing for white, but this is actually, there's a stirrer motor in there, and a motor. And that's needed because the pigments, the white pigments, are so heavy that they will settle down in the bottom and become a very hard stuff, yeah, if you don't mix it, yeah. So CMYK ink is actually more fluid. I mean, if you mix it, it's like a bottle of Coke, you know, it stays there. I mean, but white ink is more like chocolate milk, maybe. Yeah? So after a while, the chocolate will dissolve and comes to the bottom, and there you have the big layer of chocolate, and on top is just the milk. Yeah? Because the chocolate pigments, or the chocolate, it's not pigments, but the chocolate whatever, is heavier and goes to the bottom. Yeah? So you need there a permanent mixing, and that mixing is actually done by just an electromotor. The thing is a little bit, and that's very important with filling up the containers and everything, yeah, is that you should mix in such a way that you don't create air bubbles in there. So it's not a mixer like, yeah, because then it's full with air bubbles. And every small little air bubble which goes into the heads will give a blockage of a nozzle, or more nozzles if it's a big bubble, of course. So also when you fill this here, you should not take the bottle and shake with it, shake, and fill it. You can maybe do this a little bit, yeah? So it moves a little bit, and pour it in, and shake again a little bit, and pour it in, and pour the full bottle in, yeah? Not just only the top layer, but the full bottle. Every 15 seconds or 20 seconds, it turns for 10 seconds, and then it waits again 20 seconds, and then turns again, and should be permanently on. But basically, you have the main container with the stirrer in there. Then we have here a pump filter, and that goes to circulation tanks, which this is connected to the inkjet heads, and that pumps furthermore into another. A little bit lower here, like that. And then there's an extra pump which pumps this back into it. So this circulates and this circulates, but you're right that this doesn't circulate. So between the main tank And then the circulation tanks, the sub-tanks like we call them, there the ink stands still. And indeed the question you could ask, is there not a risk that in those, if you for a long time don't do anything, that there the ink would start to compact and block? Yeah, I think there is. I think there is a risk there. Never take a holiday. Always print, and if you print even not with white, so if you print on white substrates, still print regularly white ink. Print white. You might say that I lose ink that I cannot sell. Yeah, that's true, but if you don't do that, then at the moment, next week, when you have to print on a transparent material with white ink, you will be blocked and everything will fail. Yeah? So always, whenever you come back from holiday, I mean from weekend, also Monday morning, you purge the ink, also the white ink, you purge, and you print an amount of samples with white. Even if you, for the next week, and the next days, Monday, Tuesday, Wednesday, Thursday, Friday, you don't use any white, whatever, you definitely will also print and consume white ink. It's a loss, it's true. It's a loss of ink, because maybe if you the whole month don't print any white, maybe you still have to fill half a bottle of ink, maybe. And I say, I have to pay for that ink, it's expensive, and I never used it. Yeah, okay, but if you don't do it, then you might have to replace the filters, you might have to replace maybe some tubing or whatever, right? And maybe some heads if you have bad luck. Yeah? So we have an American customer who especially ordered a CMYK press. So without the white, 4-color press. We have 4 versions. We have the version CMYK white, full width, 3 heads per color, PX3000. We also have the PX2000, which is the narrow version. And then we have those two in our CMYK version or CMYK plus white version. The most expensive, obviously, is the one PX3000 with white, a 5-color version. But if you don't need a white, if you barely use white, and you have other equipment, other inkjet machines, I really suggest not to buy the one with white. Yeah? Unless you say, no, I'm going to move all my production for transparent material on the PX3000, yeah, then buy the white. But not for those 5 jobs in a month you have to do, because that's a lot of waste, a lot of risk. For printing only every 2 weeks a roll of transparent material, why would you do that? I mean, that's too much risk, I would say. Then for the web, we have unwinders, only 600mm diameter, so not big rolls, unfortunately, which makes something like 2000 meters, but that all depends, of course, on what kind of material you're printing on. On film, it might be 6,000. Indeed, that's true with 50 meters. That's what one of the complaints that people had sometimes, and say, hey, you print that fast, 50 meters per minute, and these relatively small rolls, I mean, that's every half hour I have to put a new roll on, so that's a lot of work every time. Yeah? We have a splice table, okay. We have also a web cleaner. It's a tacky roller. It's just a roller which is 1 layer of sticky material on it, and the goal is that every day you take 1 layer out of that sticky roll, so it's again freshly sticky. Yeah? And that sticky glue will pick up all the dirt. That's the goal. If you're working with very bad material, which creates a lot of dirt or has a lot of dirt, then you will have to replace that tacky glue label, let's say, twice a day. Yeah. If you don't print much, only 1 hour in a day, then maybe you can get away every 3 days you take out 1 roll. So 1 production day is typically, for normal material, 1 layer of this thing. Part of your daily routine, daily startup routine to check is the roll still tacky. And then you have also a Corona treater, which is standard. Initially it was a different brand. The one what I have in training is a different brand. It's a South Korean brand, very reliable. You can get shocks from it, so I never use it. Yeah? But we removed that and we changed it with our classic one that you also will see on GM systems. That's from Corona treater from Vetaphone. Vetaphone is a very reliable, correct, and easy to clean system, or relatively easy to clean system. So that's what you will see on new machines, what you will not see on my machine, because I still have the old South Korean whatever type. So Vetaphone, very good system, we all know it. Now the question is, do you need to use it, yes or no? Most of the time, not any. we sometimes see that even putting it on gives even worse results than switching it off. And the strange thing is that sometimes we see that on the materials where you think corona treater is not needed, like paper, we see that by switching it on paper, it gives better results. So it's sometimes a little bit opposite effect. So end story, this is something you have to try. If you feel it's better, keep it on. If you don't feel it's better, switch it off. Definitely switch it off if you don't need it. Don't say, oh, it doesn't matter, it's maybe slightly better, but I'd almost not see the advantage, yeah? Then it's better to switch it off. Because the more you use it, the more possible issues you might have in cluttering and head damages and stuff like that. So better is to switch it off if you don't really prove or really see the big benefit of it, yeah? Okay. And then we also have a lining system as well on the input as the output. These are very well-known systems from BST. They're working, not much to it. How to tweak and tune it, I will explain that later. On the machine itself, you have a couple of extra stuff, like, of course, the curing section, the static bar we also have in the machine, and we have the waste tank, because that's a nice thing. I didn't mention that yet, but what we do automatically, and that's different with some other machines in the field, like Xeikon, is that the system always will go to a kind of safety capping state. So the inkjet head is an advantage and a disadvantage. Advantage is that when we want to print, we go to the printing section where the paper is or the substrate is, and we start to print. And if we don't print, we move the heads back to capping state. And there we can jet, we can purge, we can do whatever. We can what we call spitting, that is every 5 minutes for white and every 15 minutes for the colors, we jet a little bit. That's what we call spitting. Yeah? To keep the nozzles open. That can be all done in collector's tray, in capping trays, and the liquid, the purged liquid, and will all flow to a big container as waste. So that's a big advantage, and it's automatic. So you print, and then you go to the restaurant for food, or you go whatever, automatically after a given time, you can program that, let's say 5 minutes, the system will automatically go to safe state, to capping state. And nothing can happen with the heads because the heads are all nice encapsulated in kind of capping tray. Yeah? So that's definitely an advantage. Disadvantage though is that, I think the more that thing moves forward and backwards, and if one head is not nicely turned or fixed, and I think that sometimes where you think, stitch, everything is perfectly tweaked and tuned, and then after a week, stitch problems again. And I think, how can that? But with all that moving, it's moving parts. Everything what does this a little bit doesn't have to be much. Can maybe, and it's not much. 10 micron moving is already sometimes enough to see a stitch, or to see an issue. So no, that's why we also have auto capping system. Because if you leave the machine not in capping, then it will automatically go to capping after 5 to 10 minutes. Depends on what you can program that in. We can program that. And as a service engineer, sometimes you change the auto capping to 90 minutes or so. So if you have to service the machine, that it not by automatically would go backwards. Now, if you open particular covers, then it will never go backward because it will block the motor. This is the machine a little bit laid out where all those components we just discussed are positioned. So unwinder, it came with here, unwinder, not much to it I think. And then we have a splice table where with 2 clamps we can block the paper so we can cut it there. The strange thing is that the buttons to connect or to move these clamps down are positioned here, this one and that one. And then paper goes on. Goes here to a kind of paper edge sensor, paper end sensor, but that edge is not really to correct something or so, but just to detect is there paper, yes or no. So if the paper would be finished here or cut or whatever, then this sensor would not see paper and then it will stop the machine. That's all. It's just like a paper end sensor or a paper detection sensor. It's not a one. It's not a web alignment module or so to correct something whatsoever. And then we have our corona treater and then our tacky roller or web cleaner with the tapey roller, the sticky roller. And then it goes a little bit to this system. This system is a tension control or unwinder tension control. It defines with how much tension the paper is unwinded a little bit. And so also defines how much tension is around here, that it defines that a little bit. Okay, this is actually pneumatically controlled, because over here you don't see it very well, but there's a kind of pneumatic thing that you can tweak the tension theoretically, because practically we say as manufacturer, we say no, you have to put that to exactly so much and don't touch it anymore. Don't play with that. You might think, why is that then a dial there? Yeah, because the South Koreans mounted it there. Yeah, so, but if it was Xeikon, we would have placed this more in the back inside the cabinet somewhere, so we could control it to a particular level and nobody touches it anymore. Yeah, and then we have the active aligner, as you can see. And then we have the in-feed roller. The in-feed roller is also a motor connected to that, and that's which really will define a little bit, let's say, the speed of the web. And you can compare that with the speed motor a little bit. Now, although the idea of controlling is different, the strategy of controlling is different. Then we have ionization bar and the static bar, which you can in the user interface switch on or off, but by default we switch it. We used to switch it on. And then we have, of course, our wide pinning, CMYK pinning. You see also here my picture, or the picture before marketing picture was actually incorrect. You see it's wide, space and pinning, and so that space there is needed to let the wide flow better. You need to give the wide the time to flow to make it equal, before you start fixating it with the pinning lamp. So after the pinning from black, we have the LED curing, the mercurial UV lamp or bulb curing, and then we have over here the outfeed motor. You could consider this a little bit as a torque motor, but actually it doesn't control torque. It actually controls more speed also, but the speed of the outfeed is slightly faster than the speed of the infeed. And so that speed variation or ratio, like they call it, is actually the tension control. If you let the outfeed motor run faster than the infeed roller, then you create a tension. Of course, you must see the relation between elastic material. If you have elastic material, then of course the speed of the outfeed motor must be way faster than when the tension is, or better, the material is non-elastic. If you try with an elastic material or very little elastic material to have let's say 3% speed increase on the torque on the outfeed motor, then your paper will simply snap. It will break, because it's not possible to expand the material with 3%. You understand a little bit? It's so all based on elasticity and about how much is a material be able to deform a little bit. And the more it deforms, the faster you have to put this motor. Indeed, but of course the question is how much do you stretch? So the stretch should be only, what is that, 0.5% or so. So you're not stretching 3, 4, 5 or 10%, because then indeed when you then relax, then a circle would be more an oval, or a square is a rectangle. That's true. But if you only talk about 0.5%, half a percentage, then it should not be that visible. And the rewinding is actually the same. You have that tension control again for your rewinding, active aligner and rewinding. That's all. So you see, at least you have 4 motors. You have a motor for the unwinding, you have a motor for the infeed, you have a motor for the outfeed, and you have a motor for the rewinding. There are 4 separate big servo drive motors.